Hey guys, so today we'll be talking about number patterns. So here we will be talking about some really interesting topics about number patterns, especially the term-to-term rule, which you saw in the thumbnail. So let's move on. So this will be the structure of our total lesson, and in this video we will be talking about the facts until the fifth topic, example problems related to the term-to-term rule. And remember, we mentioned about this in our thumbnail. Moving on, and now we're going to introduce you to the world of number patterns. So, if someone asks you, what is a number pattern? You can easily say that it's a list or a sequence of numbers that is following a certain rule or a principle or a formula. And this is a really crucial role in mathematics, where we use them in different types of concepts and applications, which gives us a critical insight into numerical relationships as well. So, now we're going to talk about different types of number patterns: repeating, arithmetic, and geometric. So first let's talk about the first type, repeating patterns. Now let's take this pattern for an example, 2, 4, 2, 4, 2, 4. So here we can identify that the same terms are repeating over and over and over again. The repeated terms are 2 and 4. So therefore, we can say that this pattern is a repeating pattern. And now let's move on to arithmetic patterns. So arithmetic patterns are formed by adding or subtracting a constant value from a certain pattern. If we go through this sequence, 5, 10, 15, 20, the common difference is 5, right? Because if we take the first term, a 5 is added to create the second term. And to create the third term, a 5 is added to the second term. To create the fourth term, a 5 is added to the third term. Now we're moving on to the next part, geometric patterns. So in arithmetic patterns, we talked that it's formed by adding or subtracting a constant value. But here what happens is we're multiplying or dividing. And we had to make sure that no term can be a 0 in this pattern. Otherwise, the whole geometric pattern would collapse. We could discuss an example for a geometric pattern as this one, 3, 6, 12, 24. Here it's multiplied by 2. 3 times 2 is 6, 6 times 2 is 12, and 12 times 2 is 24. So now we're going to go to our main topic, the grand one. So here we are understanding the term-to-term rule. So the term-to-term rule generally describes the relationship between consecutive terms in a number pattern. So this helps us to determine the next term in any pattern, where we determine that term using the aid of the previous term. For an example, we can consider the sequence 3, 6, 9, 12. Let's talk about that. 3, 6, 9, 12. And we're going just like that. So now if we go through this pattern, we can see that every time a new term is created, a 3 is added, right? A 3 is added. So therefore, we could easily determine this term as well, 12 plus 3. So it's 12 plus 3, which is 15, right? So in conclusion, we can say that the term-to-term rule in this pattern, not in all the patterns, in this pattern, the term-to-term rule will be add 3. This is the term-to-term rule. Okay, so now that we have it, let's make it into a huge picture. Yeah, huge text. Okay, for the term-to-term rule in this pattern is add 3. So you can use the same principle to find the term-to-term rule of other patterns as well. Even in geometric patterns, you can do the same way. Let's talk about the geometric term that we had right here. So 12, 24. Each number is multiplied by 2, right? So the term-to-term rule would be multiply by 2. So now let's go through these examples. Now if we consider the sequence 3, 6, 9, 12, just as I mentioned before, okay, we would get 15. Now we're going to this one, 1, 4, 7, 10. Okay, not the previous pattern, but hopefully it would be the same type of term rule. So it's apparently 1, 4, 7, 10. We have 1, 4, 7, 10, right? So here also, it's the same thing if we observe carefully. It's just an adding another 3. But there's only a one difference. That is, this term is going to change. Instead, we'll have to just put 13. It's just the same thing. We're adding a 3, right? 1 plus 3 is 4, 4 plus 3 is 7, and 7 plus 3 is 10. The term-to-term rule is same, but the next term would be different because the terms are different. Let's move on. And we'll be talking about this topic, position to term rule, in our next part. So in that video, we'll be talking about what is a position to term rule. Are there any simpler methods to create these, like this one? And finding consecutive numbers in a series. This is also a really interesting topic in this field. So that's the end of our video. See you in our next episode where we'll be talking about the position to term rule in number patterns. So see you next time.